Today's lesson, section 9.2a, we'll be talking about the dot product. So, a dot product is when, if I have two vectors, let's say vector u is a sub 1 comma b sub 1, and vector v is a sub 2 comma b sub 2, then the dot product denoted by vector of u dot, so like kind of like a multiplication sign in between, but for vectors it's considered dot product, dot product vector v is defined as the following. Okay, so notice that it's kind of like multiplication. You are multiplying, but you're multiplying your a values to each other, and then you're multiplying your b values together, and then you're going to add them. So you're going to have one value when you're done. So the dot product is kind of like a scalar value where it's just a number that you end up with. So if I want to find the dot product of two vectors, so here I'm given vector u and vector v. So for vector u we have 3 comma negative 5, and vector v have 1 comma 4. So for this one we would take 3 times 1 plus negative 5 times 4, and then simplify our math. So 3 times 1 is 3, negative 5 times 4 is negative 20, and then a subtract gets me negative 17. Okay. If they're in ij form, do the same thing. Remember, the i's and the j's are detached from it, so I'm just looking at the values for which I'm multiplying. So here I'll take 6 times negative 1 plus 2 times negative 2. That gives me negative 6 plus a negative 4, which is negative 10. Okay. So that's kind of what a dot product is and what it looks like. There are certain properties that go along with dot product. Dot product is commutative, so it doesn't matter which order you have them set. Number 2 is that it deals with the associative property. Okay, so you can say that a scalar times vector u and the dot product of v is the same as just taking the dot product of uv first and then multiplying by your scalar, and then actually you could switch them around. Like before here, you could switch a and the vector u around because they're commutative as well from previous lessons for vectors, and then you could take the scalar times vector v first and then take the dot product of u with that, and it would still be the same thing. Okay. The distributive property works for the dot product, so if I have a vector of w on the outside, I can distribute that vector to u and to vector v and take those dot products individually and then add that value in the end. And then also the magnitude of vector u squared is the same thing as the dot product of u to itself. Okay. Now, the dot product theorem is if theta is the angle between two non-zero vectors u and v, then the dot product of u and v is going to be equal to the magnitude of u times the magnitude of v times cosine of theta. Okay. Now, in class we'll prove this, so you can kind of see where we come up with it, but this is very important because it allows us a formula that we can actually use to help us find an angle in between two vectors. So if theta is the angle between two non-zero vectors u and v, then we can rewrite that last one by dividing both sides by the magnitudes of u and v to the other side. So cosine of theta is equal to the dot product of u and v divided by the magnitudes of u and v multiplied to one another. Okay, and so if I was going to find the angle, remember that wouldn't completely get me my angle quite yet, because you would have to take the inverse cosine to get the last part of that. So example 2 says find the angle between the vectors u and v. So first you need to take the dot product of both, and so 4 times 6 plus 1 times negative 5 gives me 24 minus 5, which is 19. Okay, so that's that first part. Now I want to take my magnitudes. So I kind of have all those together. So the magnitude of u is going to be 4 squared plus 1 squared, which is 16, plus 1, which is square root of 17. Okay? And then the magnitude of v is going to be 6 squared plus a negative 5 squared. And then that gives me 36 plus 25. And then that would give me square root of 61. Okay? So now I have all the information I need. So if I want to find the angle between that, I just plug that in. So 19 over square root of 17 times square root of 61. So I can insert that into my calculator, and that gives me a decimal of 0.59001, it looks like. Okay, and then I want to take the inverse cosine of that. Remember, leave it into your calculator. So my answer for theta in degrees should be 53.84 degrees. Okay? And so that would be how we would go about finding an angle in between two vectors. Okay? Now, something special about vectors is that they can be orthogonal. Now remember that orthogonal, and this is like a new word to you, orthogonal means that they are perpendicular. So two non-zero vectors, u and v, are perpendicular or orthogonal if and only if the dot product of u and v is equal to 0. Okay? So if you want to determine if a pair of vectors are perpendicular to one another, all we need to do is take the dot product and show that they're equal to 0. So if I have the dot product of u and v here, then 3 times negative 3 plus 4 times 4 gives me negative 9 plus 16. That gives me 7. So, not orthogonal. Okay? Because it's not 0. Let's look at the other one. A dot product v, or keep doing v, dot product of b, 1 times 12 plus 6 times negative 2. So I get 12 minus 12, that's 0. So this one is orthogonal. Okay? And that's it for today. Okay? See you in the next video. Have fun.